The story of every Sprite bottle begins deep underground. Crude oil, a complex mixture of hydrocarbons formed over millions of years, is the primary raw material for PET plastic. Extracting it carefully is the first step in creating the bottles we use daily. Once extracted, crude oil undergoes refining. Through processes like distillation and cracking, we separate hydrocarbons into different fractions. The fraction we need is purified and prepared to form the building blocks of PET plastic, ethylene glycol and terephthalic acid. PET, or polyethylene terephthalate, is a polymer formed when ethylene glycol and terephthalic acid undergo polycondensation reactions, linking together into long, strong chains. This molecular structure gives the bottles their clarity, strength, and lightweight. After polymerization, PET is cooled and cut into uniform resin pellets. These tiny granules are the blank canvas for every bottle, ready to be transformed into precise preforms through injection molding. Before molding, PET pellets are dried to remove any moisture, which is critical. Even a small amount of water can cause bubbles or weak spots during molding, compromising bottle integrity. Resin storage is carefully controlled. Temperature, humidity, and contamination are monitored, ensuring every pellet maintains its quality until it enters the molding machines. This molecular precision is what makes PET ideal for beverages. Its strength allows it to withstand carbonation pressure, while its clarity and lightweight nature make it perfect for retail bottles. From underground oil fields to high-tech polymer production, the journey of PET is both a feat of chemistry and engineering. Every Sprite bottle begins with this precise transformation of raw hydrocarbons into resilient, versatile plastic. PET resin production and preform preparation. After PET pellets are produced, they are transported to specialized molding facilities. Here, precision machines will transform these granules into the test tube-shaped preforms that will eventually become Sprite bottles. Pellets are fed into hopper systems, where sensors ensure a continuous flow into injection molding machines. This controlled feeding maintains consistent melt quality and prevents air pockets that could compromise the bottle's strength. Injection molding machines are the heart of preform production. They melt the PET pellets at precise temperatures of around 260 degrees Celsius, injecting the molten polymer into steel molds with high pressure to form uniform preforms. Molten PET flows into the mold cavities, forming the exact shape of the preform. The high precision of these molds ensures uniform wall thickness, which is critical for later stretching and blow molding. Once formed, preforms are rapidly cooled through water channels inside the mold, solidifying them while preserving their shape. Robotic ejectors remove them gently to avoid deforming the plastic. Every preform undergoes precision measurement. Laser and optical sensors detect even minor inconsistencies in wall thickness, ensuring that each bottle will later withstand internal carbonation pressure without failure. Preforms are stored in controlled environments, protecting them from dust, moisture, and temperature fluctuations. This ensures uniform quality and readiness for the next stage, stretch blow molding. During injection molding, PET molecules begin aligning slightly along the preform axis. This initial orientation is crucial for biaxial stretching in the next phase, which gives the final bottles strength and transparency. Chapter 3: Stretch Blow Molding. The embryo is only the beginning. In the stretch blow molding phase, precision machines heat, stretch, and inflate the preform into its final Sprite bottle shape, ensuring strength, clarity, and uniformity. Preforms are carefully heated using infrared heaters, softening the PET just enough to make it pliable. Temperature control is critical. Too hot and the material degrades. Too cold and it won't stretch properly. Once heated, preforms are placed into precision molds. These molds define the bottle's final dimensions, including neck finish, base design, and wall thickness distribution. A mechanical stretch rod elongates the preform along its axis. This axial stretching aligns the polymer chains in one direction, increasing tensile strength and preparing for the final biaxial orientation. Simultaneously, high-pressure air inflates the preform, forcing it against the mold walls. This radial stretching combined with axial orientation ensures the bottle achieves maximum strength and clarity, capable of holding carbonated beverages safely. After inflation, bottles are rapidly cooled to lock in molecular orientation. Rapid cooling preserves clarity and prevents deformation, allowing each Sprite bottle to maintain its shape and internal pressure resistance. Modern production lines operate at incredible speeds, producing hundreds of bottles a minute. Automation ensures uniformity, reduces human error, and maintains high-quality standards across every batch. During this process, PET molecules are oriented in two directions, axial and radial. This biaxial orientation gives the bottles their strength, clarity, and ability to withstand the internal pressure of carbonated beverages like Sprite. Chapter 4: Quality Control and Inspection. After molding, every Sprite bottle undergoes rigorous quality control. This stage ensures that each bottle can safely contain carbonated beverages without leaking or bursting under pressure. High-precision laser scanning systems measure the bottle's dimensions. Any deviation in height, wall thickness, or neck diameter can affect capping and carbonation integrity. Each bottle is stress tested to withstand internal pressure from carbonation. Burst pressure testing ensures the PET can handle both transport stress and consumer use without failure. Ultrasonic sensors measure wall thickness across multiple points. Consistency is critical. Thin areas could fail, while uneven thickness can distort the bottle under pressure. Cameras detect microscopic defects, such as bubbles, scratches, or contaminants. Even a minor imperfection could compromise clarity or structural integrity, so defective bottles are automatically removed. Impact testing simulates real-world handling. PET's flexible but strong molecular structure allows bottles to survive minor drops during packing and transport. Automation ensures that every rejected bottle is removed before filling. This guarantees that only bottles meeting all specifications continue to the Sprite production line. Quality control relies on the science of polymer behavior. PET molecules stretch and distribute stress evenly, but any structural weakness must be identified before the bottle is used. Chapter 5: Bottle Cleaning and Sterilization. Before filling, every Sprite bottle must be thoroughly cleaned and sterilized. This automated washing line removes dust, oil, and microscopic contaminants that could compromise food safety or shelf life. Bottles enter multi-stage washing tunnels, where high-pressure water jets cleanse both the inside and outside surfaces. The rotation ensures complete coverage, preventing any dead spots where contaminants could remain. After washing, food-grade sterilants are applied. Chemicals like paracetic acid or ozone disinfect the interior, eliminating bacteria and ensuring the bottles meet strict hygiene standards. High-pressure air jets dry the bottles instantly, removing residual water that could dilute the beverage or interfere with carbonation during filling. Robotic systems handle the bottles with precision, minimizing human contact and preventing contamination. Every bottle is monitored for proper orientation before reaching the filling line. Sensors ensure that no chemical residue remains. This ensures food safety while maintaining the PET's clarity and integrity. Once cleaned and sterilized, the bottles are ready for filling. This meticulous process guarantees that every Sprite bottle entering the production line is hygienic and safe for consumption. The science behind cleaning combines fluid dynamics, chemical sterilization, and mechanical precision. Each step is engineered to maximize hygiene without damaging the PET structure, maintaining bottle strength and clarity. Chapter 6: Filling with Sprite. Once bottles are cleaned and sterilized, they enter the filling hall. Here, precision machinery ensures that each Sprite bottle receives the exact amount of carbonated beverage, maintaining quality and consistency. Sprite's signature fizziness is created by dissolving carbon dioxide into water under controlled temperature and pressure. Maintaining the right CO2 concentration ensures consistent taste and effervescence. The sweet syrup is blended into the carbonated water with precision volumetric pumps. Accurate ratios maintain flavor consistency while preventing foaming during filling. High-speed rotary filling machines fill hundreds of bottles a minute. Each head precisely controls flow, preventing foam overflow while preserving carbonation. Sensors constantly monitor internal pressure, ensuring bottles are not overpressurized. Correct pressure protects both the PET structure and the carbonation level, guaranteeing safety and quality. Filling and capping are perfectly synchronized. Bottles move seamlessly from filling heads to capping stations, reducing contamination risk and maintaining a high throughput of production. The carbonation process is delicate. Rapid bubbles indicate proper carbon dioxide dissolution, while uniform distribution ensures every sip delivers the crisp, refreshing fizz Sprite is known for. Carbonation relies on gas solubility and pressure equilibrium.